of beer before? Well, then you're drinking this compound right here. This is ethyl alcohol. This is methyl alcohol. It's used for cleaning and stuff like that. As you can probably tell, the denoting feature of the alcohol is this OH group right here. This is isopropyl alcohol. It's used for cleaning wounds and the like. It's the thing you put in your wounds when you want to disinfect them. This is the basic form of the alcohol in organic chemistry, where the R group is some random carbon-containing compound. This is diethyl ether. It's used as a solvent in a lot of chemical reactions because these carbons right here have a positive charge, a delta positive, and this oxygen right here has a delta negative. A good solvent has a positive end and a negative end. Diethyl ether is the most common form of the ether functional group, but it is not contained to just diethyl ether. You can put as many carbons on either side as you want, and they don't even have to be the same. Here is the basic form of the ether, where the R groups are carbon-containing compounds. This here is methyl aldehyde. It has this double-bonded oxygen right here. Now, it's ethyl aldehyde, and now propyl aldehyde. Depending on what substituents are on this carbon here, it will tell you what kind of aldehyde it is. But the main feature of the aldehyde is this double-bonded oxygen and this hydrogen attached to this carbon. This is the basic form of the aldehyde, where R is a random carbon-containing compound. This is acetic acid. It's a carboxylic acid functional group, and it's actually pretty common in most households. This is vinegar. This is the reaction between vinegar and baking soda that you probably did as a kid. This is the baking soda, sodium bicarbonate. This anion here comes in, takes this hydrogen, and gives the electrons back to this oxygen, giving this product. And the anion of this. When the substituent on this end is a carbon, or a carbon substituent, it is called a ketone. This is the basic ketone functional group, where the R groups are random carbon-containing compounds. And again, they don't have to be the same. This is an ester. This group here, you will learn later, is a great leaving group, meaning it can be replaced with a different compound, changing the chemical composition. Here's the basic form of the functional group of ester. R can be any carbon-containing compound. Ester groups can be replaced with ammonia to form amide compounds. Again, here is the amide, where R can be any carbon-containing compound. This is ethyl iodide. It's a haloalkene. This is the basic form of the haloalkene, where R is a carbon-containing compound and X is a halogen. One of these. This is methylamine. You may recognize the name of the compound from a certain TV show. This is the basic form of the amine functional group, where R is a random carbon-containing compound. This is an arene group, where R is a random carbon-containing compound attached to a benzene ring. I've drawn out a molecule here. Can you identify the functional groups? Give the video a pause if you need to. There are two functional groups here. There's an alcohol group here. Alcohol. And a carboxylic acid group right here. I've drawn out another molecule. Can you find the functional groups? Pause the video if you need to. There are two functional groups here. There is an arene group, arene, and a ketone group. Here's another compound. Can you identify the functional groups? Pause the video if you need to. There are three functional groups here. There is an ether group right here, an aldehyde group right here, and a carboxylic acid group right here. And now you know how to identify organochemical functional groups. Good job.